My dear cute cuties, my future doctors, and today we are going to discuss electrostatics. எல்லாருமே இங்க இருக்கா? Voice, video, everything perfect ஆ இருக்கா? Cuties, my future doctors, and today we are going to discuss electrostatics. எல்லாருமே இங்க இருக்கா? Voice, video, everything. Okay. Now sort ஆச்சு. Okay. Now tell me everything is perfect. Yes, Lakshmi, good afternoon. Yes, voice, audio, I think it's perfect. I can hear it from here. Okay. Yes. So, what we are going to discuss, we are going to discuss the chapter that is nothing but electrostatics. Okay. So, in the electrostatic chapter that we are going to discuss today. So, ellarume ready? Perfect. Yes. Yes. Bliss Mary, right? Yes. Okay. So, electrostatics, as we have, in the part 1, we have already done, we have discussed about the electric charge, electric field, the Coulomb's law, and also we have discussed about the Gauss's law. We have discussed electric field due to different cases. Everything, all the equations, everything important. So, adinala and the session miss pannitena, ippave you can just watch it and you can just study. So, in the session, we are going to discuss few of the topics. Like the first one is nothing but we will be going for the electrostatic potential energy. Electrostatic potential energy. Adikapram we will be going for electrostatic potential. Adikapram we will be going for the important one, the relation between E and V. Also adikapram we will be going for electric dipole. So, this is our target. We will be finishing all these topics. Okay, Vada? Everybody is ready to study this topic, yes or no? Yes or no? Yes, yes, Gokul. Yes, everybody is ready. So, first we can just start with the electrostatic potential energy. Okay, we can just start with the topic that is nothing but electrostatic potential energy. So, first you should understand the electrostatic potential energy na enna. So, let us say, while we were discussing about in the last class we have started this. I'm going to repeat it again. So simple the potential energy the first I'm going to discuss. Okay, what is this potential energy? So the most favorable what is a mostly we know the gravitational potential energy. High NOH, right? Yes. So, you should tell me what is this gravitational potential energy? Could you please let me know in the chat box what you have studied or what you understood about the gravitational potential energy? Can I let me know in the chat box, everybody? Please let me know in the chat. What is this gravitational potential energy? Which means we can say that if I'm lifting something, okay, if I'm lifting something, actually I'm doing a work against the gravitation force, okay. Gravitational force against I'm doing some work. And the work actually stored as the potential energy. So, I'm just going to define generally, in general, this potential energy ennana, it is nothing but the work done against the what is nothing but the what is a conservative force. Okay, conservative force. So when I'm talking about this gravitation, on the case gravitational force in the conservative force. Ana in the chapter la varumbodhu in the conservative force na electrostatic force da. Okay, electrostatic force da. So now I can just tell you. So inga we have an electrostatic force. So now the thing is like when I'm just defining electrostatic potential energy, I can say that the work done against the electrostatic force is stored as the potential energy. புரிஞ்சுதாடா? Understood na? Give me a heart in the chat box, everybody. If you understood this potential energy term na, just give me a heart in the chat box. Okay, so simple as now we can say the work done against the electrostatic forces stored as the electrostatic potential energy. So first one and the definition we have done with it. Okay, so next one the 1 second. Okay, so next one the what we are going to do is nothing but, let us say, we have discussed about this potential energy, correct? So now, again going back to the gravitational potential energy. You will be just taking something from the ground and we are just keeping at a height h. Now, what you will say? mgh as the potential energy. Correct? So, you should understand, we cannot define or we cannot say exacta in the point potential energy or value ivloda. And the madri we cannot tell about the potential energy. Purinjidada? So, very important concept da. Very important concept da. When I am talking about potential energy, idellame general I am telling you. Okay, potential energy concept da. If now I am just telling you. So, potential energy na, ipo you cannot just simply, okay, in the point potential energy exacta in the value. I cannot say that. Always, we used to mention change in potential energy. Change in potential energy. In case of gravitation potential energy also. Okay, in the case of gravitational potential energy also, the one thing you should know is, let us say, if I am talking about the gravitational potential energy at a height h, okay, you will say mgh. Ana, neenga oru reference point consider pannirukka. And the reference point da in the ground. Okay, ground level. Okay, when you're talking about the ground level, and the ground level irukkiradhu 0 da. With respect to this ground, the potential energy at this point or at a height h mgh da. So, eppavume we used to say change in potential. So, change in potential na final minus initial. Ana in the initial point da, usually we will be take it as the reference point, and in the reference point la we will assume the potential energy 0. Purinjidada? Everybody understood? So, simple ana concept, general we are just discussing this. Yena in the concept in the general idea if you understood na, in the chapter easy agapore. Okay va? So potential energy is nothing but the work done against any conservative force da, and in the chapter la and the conservative force na electrostatic force da. Correct? Adukapram we should talk about the change in potential energy. Eppavume whenever we are talking about potential energy na, adu change in potential energy da. Yena specific in the point la irukra potential energy we cannot define. Eppavume oru reference point irukkanum, and the reference point la we will consider the potential energy as 0. When it comes to the gravitational potential energy, we used to take and the ground level la irukra potential energy 0. Adha reference. And the reference point பார்க்கும்போது இந்த பாயிண்ட்ல potential energy mgh. புரிஞ்சுதாடா everybody? So இதுதான் நம்ம concept. I hope you got it. Yes or no? Please let me know in the chat box if you understood the concept. Please let me know in the chat box. Please let me know in the chat box. In the general idea mattum podum, in the chapter it is going to be easy, and you can also study this chapter along with gravitation. Yena gravitation chapter la if you are just comparing this to simpler, you can just study. You don't need to put much effort for studying a new chapter. Gravitation, magnetism, as well as this electrostatics, you can just study it together. So, as I mentioned, you need to study only one chapter, the rest you will be get it automatically. Yes, Radha. Thank you so much. Thank you so much. Okay. So right now we got this points. Now we are coming back to electrostatic potential energy. So what I said, electrostatic potential energy is nothing but the work done against the in the case of electrostatic force. Okay, electrostatic force is stored as electrostatic potential energy. Okay va? So next sentence வந்து இங்க ஒரு reference point இருக்கணும். கரெக்ட்டா? இங்க வந்து ஒரு reference point இருக்கணும். அந்த reference pointல we will consider the potential வந்து 0 தான். And when it comes to electrostatic potential energy, அதுல இருக்கிற reference point வந்து we are considering at infinity. And அந்த infinityல இருக்கிற potential energy வந்து 0 தான். புரிஞ்சுதாடா? So எப்பவுமே whenever we are discussing about potential energy na, you should have a reference point. When it comes to electrostatic potential energy, and the what is a reference point வந்து infinity da. So infinity ல இருக்கும்போது it will be getting 0 as the potential energy. So எப்பவுமே potential energy na, electrostatic potential energy na, we used to refer with the infinity, then we will be giving the value. புரிஞ்சுதா? புரிஞ்சுதா? You will be getting in this week itself, Radha. No worries, okay? Books வந்து யாருக்குமே கிடைக்கல, so you can just wait for few more days. Okay, in the weekல you are going to get it. Okay, so இதுதான் வந்து பேசிக்கான fact, electrostatic potential energy, work done against the electrostatic forces stored as the electrostatic potential energy, and இதுல இருக்கிற reference point என்னன்னா அது வந்து infinity தான், and infinityல இருக்கிற potential energy வந்து 0 தான். புரிஞ்சுதாடா? It is, this is what we need to discuss. Now let us say, இப்ப வந்து இங்க ஒரு charge இருக்கு, அது வந்து I am mentioning it as Q. Okay, now இன்ஃபினிட்டில ஒரு பொட்டன்ஷியல் ஒரு சார்ஜ் இருக்கு, அதுதான் வந்து Q. புரிஞ்சுதாடா? இப்ப வந்து we have a charge capital Q. இன்ஃபினிட்டில வந்து again one more இருக்குடா, we will discuss everything, no worries. Okay, a formula sheet as well as we will be discussing about the mind map, everything we will discuss in the coming month. Okay, so right now electrostatics part 2 da, so let us focus on that. Okay, so those who have joined right now, you can just like this video, also share with your friends. Yena vanda many students are struggling with this chapter. So now vanda, as I mentioned, anga infinity la oru charge irukku, and the charge vanda positive da, in the charge kuda positive da. So now my question is, what kind of force will be in between if I am bringing this charge towards close to capital Q na, அங்க இருக்கிறது repulsion attraction ஆடா. Two charges இருக்கு, ரெண்டுமே வந்து positive தான். So one is at infinity and I wanted to take that charge at infinity to a point which is close to capital Q. அப்படினா அங்க இருக்கிறது அந்த two charges குள்ள இருக்கிற force வந்து it is going to be attraction or repulsion. Can you give me the answer in the chat box? Quicker you can give me the answer. இங்க இருக்கிறது it is going to be attraction illa repulsion. Attraction or repulsion. So ரெண்டுமே வந்து positive charge தான். Correct? Two charges in the capital Q and small q வந்து positive charge. So which means அது வந்து repulsion. Correct? So இப்ப வந்து if I am talking about the electrostatic force na, in the charge வந்து it will repel that charge. And that charge will also repel this charge. Very good Lakshmi, very good Akshaya, right? Yes, very good. புரிஞ்சுதாடா? So இப்ப வந்து in the capital Q வந்து it will repel it. Which means electrostatic force வந்து இந்த directionல இருக்கு. Which means infinityல இருந்து I am keeping this charge at a distance r from capital Q na, இந்த Q ல experience பண்ற force ஓட direction வந்து இப்படிதான் இருக்கும். கரெக்டா? இதுதான் வந்து the electrostatic force ஓட direction. ஆனா வந்து what I'm doing, I am actually, which means the external force. Okay, இப்போ வந்து இந்த external force என்ன பண்ண போற? Yes, it is taking this charge towards here. Which means in the external force வந்து actually doing some work against the electrostatic force. புரிஞ்சுதாடா? I hope you are getting the point. இப்போ வந்து இந்த infinity ல இருக்கிற இந்த charge இல்லையா, அந்த charge வந்து I need to keep it close to capital Q. அப்படினா இந்த capital Q வந்து repel பண்ணுவா. கரெக்ட்டா? It will repel the charge. In the small q it will repel. அதுதான் what I have mentioned in the electrostatic force வந்து repulsion இருக்கும். இப்ப வந்து if I'm just trying to keep it also, this charge will exert a force and this will move away from the charge. ஏனா அங்க இருக்கிறது repulsion na, as we know electrostatic force ஓட direction வந்து இப்படிதான் இருக்கும். Now I'm talking about external force, which means I am taking this charge. Okay, I'm taking this charge. I am applying some force in this direction. Okay, I wanted to overcome this electrostatic force. Okay. Gokul, nice teaching. Thank you so much, da. Thank you so much. Okay. So, inga vanda, in the small cube vanda, what is happening? So, inga irukkiradhula electrostatics vanda and the direction la irukke. And I am taking this charge in the opposite direction of electrostatic force. Appo vanda I can tell you na, work done against the electrostatic force has been done. Yes or no? Tell me. Can I say that? Work done against gravity, work done against electrostatic force is done right now? Correct? Yes or no? Tell me. Yes or no? So very simple. Anga infinity la irukra oru charge I am keeping it close to the capital Q. So anga varumbodhu electrostatic force vanda it will be a repulsive force. Ana external force vanda actually acting in the opposite direction of electrostatic force. So adanala we can say that we have done the what? Yes, work done against the electrostatic force. So definitely வந்து இங்க ஒரு potential energy இருக்கும். Correct? And the potential energy oda equation வந்து I'm going to write it here. K into Q divided by the distance of separation. Okay. And the potential energy oda equation வந்து K Q divided by R தான். புரிஞ்சுதாடா? Of course, Akshaya, it is possible da. ஆனா வந்து கொஞ்சம் extra work பண்ணணும். Okay. It is not easy. புரிஞ்சுதா? So, இப்போ வந்து I can also say that in the potential energy is nothing but the work done by the external force. Correct? Now, I just wanted to write in terms of work done by electrostatic force. Can you give me the equation for that? I'm coming to it, Google. Just hold on. Okay. So, இப்போ வந்து I wanted to write potential energy in terms of work done by electrostatic force. Can you give me the relation in the chat box? Work done by external force vanda we have already written. Okay, va? Work done vanda we have already written. Appadina, now my question is the potential energy in terms of electrostatic force. So, அது வந்து nothing but minus electrostatic force. புரிஞ்சுதாடா? External force பண்ற work done வந்து exactா stored as the potential energy. If you are trying to write in terms of electrostatic force, இல்லனா conservative force ஓட termல வந்து if you need to write it na, அதுல வந்து potential energy will be equal to minus work done by the electrostatic force. ஏனா அந்த electrostatic force and the displacement you can just check it. Okay. So அதுல இருக்கிறது வந்து you can just say that the potential energy வந்து exactா going to be negative. And in the relation வந்து we have studied in work energy power as well. Okay. The potential energy வந்து it is nothing but equal to the work done, negative of the work done by conservative forces. Okay. And the statement வந்து அங்க we have studied and now we are using over here. புரிஞ்சுதாடா? If you understood, now give me a quickly, you can give me a fire in the chat box. Give me a fire in the chat box. Everybody give me a fire in the chat box. If you understood this concept potential energy, na, give me a fire in the chat box. Yes, thank you. So right now, we are going to find, thank you so much guys, potential energy due to system of charges. Okay, system of charges. So, inga vanda I have a capital Q, I have Q1, I have Q2, I have Q3. So, inga vanda paakumbodhu, let me just write it as R1, idu vanda R3, idu vanda R2, and inga irukkiradhu R12, inga irukkiradhu R23. So, இந்த மாதிரி distance ellame they have given. So, இப்போ வந்து பாக்கும்போது we have 4 such charges, correct? So, இதோட complete the total potential energy da question in the system in the 4 charge system total potential energy da தேவையா இருக்கு. So, அப்படினா first வந்து I'm just considering Q and Q1. So, that will be coming as K into Q1 divided by R1 plus next வந்து in the 2 K into Q1 Q2 divided by R12 plus K into Q2 Q3 divided by R23 plus we have another one K into Q into Q3 divided by R3 plus again this one is there. So that is again K into Q into Q2 divided by R2 plus again in the two charges irukku, in the two charges irukku. So I'm just marking it as R13. Okay, so we are just writing that as well, K into Q1 Q3 divided by R13. I hope all the terms we have written. Okay, va. So we have understood it is the total system and the potential energy of the system of charges. So let us say charges same marke, distance kuda same marke. Appadina you should find the potential energy. So adakaga you can just do one thing. You can find the potential energy between any two of the charges and you can multiply with the number of or how many pairs it will come. So and the madri the possible pairs if you need to find na, okay, possible pairs if you need to find na, you can use this equation n into n minus 1 divided by 2. So in the case how many charges we have? 1, 2, 3, 4. So we will be getting 4 into 4 minus 1 will be 3. So we will be getting 6 terms. Correcta? We got 6 terms as well. Purinjida? Everybody understood? So this is the simple concept. If you need to find the potential energy due to a system of charges, we need to add the individual potential energies. Which means in the two charges, potential energy K into Q into Q1 divided by idoda distance of separation, adu vandu R1. Next we will be taking another one. So in the madri many pairs irukkum. So ipa as I mentioned, we have few charges and the all charges equidistant and all charges value same appadina adula irukra potential energy you can find the possible number of pairs into one the potential energy due to one set of charges. Next one important thing is like in the potential energy na idu or scalar quantity da. Scalar quantity we know, let us say this is Q1, this is minus Q2, this is Q3. Okay, in the distance let us say A, in the distance A, in the distance kuda A. Correct? So appadina idhula irukra potential energy oda value it will be coming as K into Q2 and I have to keep a minus sign. Yena idu or scalar quantity da. So adinala in the charge order magnitude kuda we have to mark it. So adinala we will be getting minus K Q1 Q2 divided by, okay, divided by A plus another pair. Adu kuda minus da. K Q2 Q3 divided by A again plus K Q1 Q3 divided by A. So this is the total potential energy. So whenever you are calculating potential energy definitely you should do one thing. You should always go for the the charge order polarity as well. If the negative charge you have to keep the negative sign as well. Purinjidada, everybody understood? Yes or no? Give me a fire in the chat box if you understood. If you understood, give me a fire. Quick you can give me a fire. If you understood na, quick you can give me a fire. Okay, va? Let us move on to the next one. Okay, thank you Lakshmi, thank you so much. So, as I mentioned, this is how we will be finding. Let us say, just check what are the possible number of pairs. So, when I'm just going for it, n into n minus 1 divided by 2 da, n na 3 da, so 3 divided by 2, 3 into 2 by 2 it will come. So, we will be getting 3 pairs. Purinjida? So, in the same case, let us say, in the same case, equal charges are okay, equal charges da, equal distance da. Appadina how we will be finding the total potential energy of the system? We will find the individual one, which means K Q square divided by A. Correct? And we will multiply with the number of pairs possible. So 3 charges na adula irukra possibility 3 da. Okay, 3 pairs irukum. So in the case la paakumbodhu you can say 3kq square divided by A da idoda total potential energy. Ipo I am going to do another one. So inge irukkiradhu q, inge irukkiradhu minus q, inge irukkiradhu plus q, same distance of separation. In the case, what is going to happen, guys? What is going to happen? Now, in the 2 nala, we will be getting kq square divided by 2. This is minus. Correct? Yena q into minus q da. Purinjida. Next again minus kq square divided by a da. Again minus because minus q into q. Again we will be getting plus kq square divided by a. So idhula vandu paakumbodhu two terms vandu cancel agum and total vandu we will be getting minus kq square divided by a. Purinjida everybody? Purinjida? AK. Okay, hi. Okay, understood, yes or no? Please let me know. Understood, yes or no? Everybody? Everybody? Yes, very good, very good. So, this is how we will be finding the potential energy of a system of charges. Purinjidada? So, now let us move on to the another term that is nothing but electrostatic potential. Okay, electrostatic potential. So, in the case, simple, I am just going to tell you. Now, you understood what is potential energy, right? What is potential energy? The work done against the electrostatic force when we are taking a charge from infinity to a point at a distance from the charge that is equal to r. Appadena, if we are taking, okay, previously we said potential energy we said we are taking a charge q. And the q charge unit test charge na, which means adoda magnitude vanda 1 unit na, and the potential energy will be converted as a potential. Which means we can say that in the electrostatic potential na, adu kuda work done against electrostatic force da, okay, electrostatic force da, ana the charge which we are bringing, okay, charge which we are bringing supposed to be a unit charge, which means in the case of potential energy we know work done da, okay, work done by external. Appadina in the case of potential vanda work done by external divided by the charge q. Purinjida? The charge per unit, the work done per unit charge da in the potential. Simple da irukku. In the two concepts vanda same da, only one difference irukku. Potential energy purinjiruchuna idu vanda easy da. Potential energy la q da we are bringing at this point. Ana potential la varumbodhu in the q vanda unit test charge ah irukanum. Adu mattum da condition ah irukku. So work done per unit charge will be coming as the potential, and in terms of electrostatic force it will be coming as minus work done by electrostatic force divided by the charge. Understood? So potential usually this is also a scalar quantity, and usually we will say the unit as volt, and this is also equal to joule per coulomb. Ena work done joule da, and in the charge adoda unit coulomb da. So joule per coulomb also we used to mention for the potential. Okay, and another important point is you should write now, okay, we will study it later. This potential will decrease in the direction of field, in the direction of electric field. In the point kuda important da, I mean in the potential in the point kuda important da, everyone should study this as well. Okay, and this is a scalar quantity, so even though it can have 0, plus, minus, all the values are possible. Okay, and potential will decrease in the direction of electric field. And also if you are finding the potential due to a negative charge na, adu vandu negative agum. Scalar quantity da, so negative charge la vandu you have to keep the negative sign. So negative charge ku vandu potential vandu negative aga pore, positive charge ku vandu potential vandu positive aga pore. Purinjidada everybody? Yes or no? Yes or no? Please let me know. Please let me know. Please let me know in the chat box, everybody. electrostatic potential that we have discussed right now. We understood that இது வந்து work done against electrostatic force தான். Okay, ஆனா per unit charge இருக்கணும், which means அந்த infinity ல இருந்து the charge which we are bringing to a point close to the capital Q, அது வந்து எப்பவுமே it should be a test charge, which means அதோட magnitude வந்து 1 unit இருக்கணும். புரிஞ்சுதா? So this is what the unit and everything, and this statement is very important. Potential will decrease in the direction of electric field. I hope you guys got it, yes or no? Please let me know. Yes. So now we understood in the potential na the work done divided by charge da. So this Q into delta V, which will be giving you the work done. Okay, just I have rearranged the equation, nothing else. I have not done anything new. I have just made Q into delta V as the work done. புரிஞ்சுதாடா? புரிஞ்சுதா everybody? Next வந்து we should find the potential due to point charge. As we know, work done na adu vandu potential energy illaya. So adanal I can say that K into QQ divided by R, idudha vandu work done divided by Q, idudha vandu potential. So I'll be getting KQ by R, which is equal to the potential. So idudha vandu the potential due to a point charge. Important ana relation, you should know this at any time. If I'm asking even while you are sleeping also, in the equation vandu you should know it. Purinjidada? Purinjida? Next vandu we are going to discuss the potential due to ring, the point and along the axis. Okay, which means the same thing we have done for field as well. So ipo vandu idudha vandu nama ring, idhula irukra radius vandu r da, and I'm taking a point at a distance x from the center along the axis, and this distance is given as small r. அப்படினா இதோட potential at this point P வந்து, okay, potential at P வந்து nothing but KQ divided by root of R square plus X square. In the relation kuda important da. I hope you remember the field equation. In the case la vara field equation vanda, it is nothing but KQX divided by R square plus X square all to the power 3 by 2 da. Correct? So this is what is happening in the field. And when it comes to the ring potential, this is going to be the along the axis. Okay, the point along the axis. Okay, so adoda expression vanda KQ divided by root of X square plus R square da. Now I just wanted to know the potential at the center of the ring. At the center of the ring. Can you give me the answer for this question? The potential at the center of the ring. Can you give me the answer? In the equation we know that at a distance x வந்து KQ divided by root of R square plus X square da. அப்படினா in the center point O ல இருக்கிற, okay, the potential at O, and the center point ல இருக்கிற potential வந்து, can you give me the answer in the chat box? Everybody, can you give me the answer in the chat box? Can you give me the answer in the chat box, everybody? What is going to be the potential at the center of the ring? So, adakaga what we are supposed to do da? What we are supposed to do? So, we know that at the center na, in the x value will be coming as 0. So, and the value one you have to substitute here. So, KQ divided by root of R square plus 0. So, which will be again come as KQ by R. So, at the center of the ring, what will happen? The potential will become KQ divided by R. Okay, vada? So, next one, we are going to find the potential at different points of a hollow sphere, or let's say a spherical shell. So, in the case, we know that இதுதான் வந்து நம்ம hollow sphere. Okay, so இதுல இருக்கிறதுல we know இதுதான் வந்து இதோட radius capital R. So now I just wanted to know the potential at point A, B as well as C, which means outside and the surface as well as the inside point. So now if we are just checking on the outside, okay, the potential at the outside, that will be coming as KQ by R. So in the case R is nothing but the distance from the center to the point A, which means இதுதான் வந்து நம்ம R. Okay, now at the surfaceல வர போறது KQ divided by surface அந்த பாயிண்ட்ல இருந்து சென்டர்ல இருந்து அந்த பாயிண்ட்ல இருக்கிற வேல்யூ தான் we need it. So அது வந்து it is nothing but KQ by R. So இந்த கேஸ்ல இந்த small r will become capital R. Next on the inside point da. So while you are finding inside point, we already know the electric field inside a hollow sphere vanda 0 da. Correct? And we will also study one relation after this. E is equal to minus dV by dr. So in the case in the field 0 na, as per this equation, you can understand V will be constant. Okay, so the potential inside a hollow spherical sphere வந்து constant ஆக போற and அதோட value வந்து equal to what at the surface. So now I can say அதோட value வந்து KQ by R தான். So now we were discussing about the potential due to a hollow sphere தான். அந்த hollow sphereல outside வர போறது KQ divided by small r தான். So in the small r na enna, small r na enna, it is again very simple. அது வந்து the distance from the center. Okay, distance from the center to the point where we need to find the field. புரிஞ்சுதா? அதுக்கப்புறம் we were studying about the surfaceல இருக்கிறது KQ by R தான். அந்த momentல small r will become equal to capital R. அதுக்கப்புறம் we have studied inside pointல வரும்போது it will be coming as the field is 0. field 0 னா அதோட meaning வந்து potential constant ஆ இருக்கணும். So constant ஆ இருக்கிறதுனால அதோட value வந்து it will be same as the surface. புரிஞ்சுதா? Each and every equation வந்து important தான். So you can just note it down. All the equations வந்து you can just note it down. All the points, everything you can write it down. All the important formulas da. So inside, outside, also on the surface, you can just note it down right now. Outside one the KQ by small r, surface la KQ by capital R, and inside one the again it is same as the surface KQ by capital R. Purinjidada? Everybody understood? Yes or no? So next one the non-conducting solid sphere da. Okay. Non-conducting solid sphere da. So idhula vandu outside no confusion KQ by small r. Surface ila kuda there is no confusion KQ by capital R. Inside da we will be having confusion. Yena in the solid conductor la we know that field vandu 0 illa. Idukku vandu value irukku. So adanala when you are calculating the potential, you will be getting KQ divided by 2R cube. Okay, so in the inside point when you are just finding the potential na, that value will be coming as KQ by 2R cube into 3R square minus R square. Okay, idhula vandu capital R is nothing but the radius of the sphere. Small r na the distance, which means ipo vandu idudha vandu nama sphere na in the distance inside point la I wanted to find the field at this point na, and the distance vandu small r. Okay, so idudha vandu the value, the potential inside the conducting solid, non-conducting solid sphere vandu it will be coming as KQ divided by 2R cube into 3R square minus R square. Purinjudada everybody? Yes or no? Yes or no? Now my question is, as per this equation, at the center, okay, at the center of the non-conducting solid sphere la irukra potential, what is going to be that? Can you give me the answer now? Hi, dreamy girl, good afternoon. Can you give me the answer for this one? At the center of the non-conducting solid sphere, when you are finding the potential, now what you will do? You will put in the R value, center point, in the R value will be coming as 0. Appadi I'm going to substitute, okay? I'm going to substitute center la varumbodhu KQ divided by 2R cube into 3R square. So idhula vandu paakumbodhu you will be getting 3 by 2 KQ by R, which means I can also say 3 by 2 into the potential at the surface. Okay, 0 alla at the center la varumbodhu in the small r oda value mattum da 0 aga pore, and while we are substituting we will be getting at this center the potential is nothing but 3 by 2 times of the potential at the surface. Purinjidada? Yes or no? Give me a yes or no in the chat box. Now we were discussing about the potential due to the non-conducting solid sphere. So adala outside and surface one the same as the hollow sphere. Adikapuram when it comes to inside, anga vandu constant value da, ana inga varumbodhu you should study this equation. Idoda derivation syllabus la illa, so you can just completely skip it. You can study this equation. Adikapuram you can just go for, if it is at the center now, in the small r vandu 0 aga pore. So while you are substituting, you will be getting at the center it will be equal to 3 by 2 times the potential at the surface. Everything is okay, perfect. Give me a heart if you understood, everybody. If you understood, give me a heart quickly. Quick, you can just give me a heart in the chat box if you understood this concept. If you understood this concept, quickly you can give me a heart in the chat box. Okay, so now we are moving on to the next one. Okay, next one na idavada easy ana concept. Okay, you might have heard this this word. It is nothing but potential difference. Okay, potential difference, or let's say we used to say voltage, correct? So in the terms allame vandu you guys know it. Thank you Lakshmi, thank you Evening Star. Okay, why that name Evening Star? Okay, so right now we are going to discuss about the potential difference. Potential difference na very simple. Okay, so ipo vanda we have a point A here, we have a point B over here. Okay, now it is asked for VB minus VA. Idha vanda they have asked, which means in the point VB na final, okay, VA na initial, which means the meaning of this potential difference, or let's say VB minus VA na, when you are taking a charge from point A, okay, ipo vanda you are taking a unit charge, unit test charge from A and you are keeping it to B. Okay, you are taking the charge from A to B. So on the point from A to B, okay, you are just taking the charge from A then to B. Correct? So, on the point, what is the work done you have done? Okay, the work done required, or let's say the work done by the external to keep, or let's say to take the charge Q0, or let's say the test charge from point A to B is known as the voltage, or let's say whatever we are calling the potential difference. So, appadina, I can just say in the VB minus VA vanda, I can just say that the work done used from, or let's say work done we have taken for bringing the charge from A to B divided by the unit test charge. Okay, Vada? Everybody understood? So this is how we will be writing. Otherwise, we can also say minus of work done from A to B by electrostatic force. Idu vandu external da. Okay, when I'm keeping minus sign, you should understand adu vandu electrostatic force da divided by the unit test charge. Purinjidada? Everybody understood? So ipo vandu whenever you are finding the potential difference na, very simple ana concept. Ipo vandu in the point A la irundhu I am taking a charge Q from A to B. So on the time la, what is the work done by me per unit charge? Adha vandu potential difference. If you wanted to write in terms of electrostatic force na, the negative of, Okay, the negative of work done by electrostatic force from taking a charge from A to B divided by the charge. புரிஞ்சுதாடா? மறக்காம லைக் பண்ணிக்கோ. Also share with your friends. இந்த chapter வந்து அவ்வளோ important ஆன chapter தான். ஓகேவா? So next வந்து I hope you got it, the potential difference and how to find it, and that is over. Now we are going to study the important relation between V and E. That is nothing but E is equal to minus dV by dr. Or we can also go for minus dou by dou x of V, okay, plus dou by dou y of V plus dou by dou x of Z, and you can just keep the direction as well. Okay, so இதுதான் வந்து okay, இதுதான் வந்து நம்ம electric field, which means if I'm giving you, okay, if I'm giving you the potential as x square plus y, now you guys have to find the electric field. Na first வந்து you should find dou by dou x of x square plus y. So while you're doing this, what you will be getting? இதுல வந்து you will be getting 2x. Correct? Next வந்து you will be writing dou by dou y of v, which means x square plus y. So இதுல வந்து x square அது வந்து 0 ஆகும், ஏனா we are differentiating with respect to y. So only there will be dou y by dou y, which will be giving you 1. So now I'm not taking the z term because ஏனா இந்த term இல்ல, இந்த potential z term இல்ல. Now electric field காக we know that this will be coming as minus dou by, minus of dou by dou x of v I cap plus dou by dou y of v j cap da. So minus, what is this value? It is coming as 2x I cap plus in the value வந்து 1 j cap, which means you can write minus 2x I cap minus j cap will be coming as the electric field. புரிஞ்சுதாடா? Understood na? Give me a thumbs up in the chat box quickly. So now we were discussing about the electric field and potential oda relation da. So and the relation very 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 important da. எங்க வேணாலும் you can just put the stars. அவ்வளோ important da. ஏனா directா வந்து questions கேட்கலாம். அது மட்டும் இல்ல, some questionsல வந்து this you have to apply, then only you will be going to the next step. அந்த அளவுக்கு important da. Majority ஆன questionsல வந்து இந்த concept we are using. So அதனால இந்த relation வந்து மறக்காம you have to study. Okay, so இப்ப வந்து ஏதாச்சும் relation கிடைச்சேனா இந்த potentialக்கு வந்து if you got a relation, first வந்து simplify, you should find dou by dou x of v, அதுக்கப்புறம் dou by dou y of v, and அதுக்கப்புறம் you should go for dou by dou z of v. So adhula irukra terms oda with the direction you will be marking, and don't forget to put the minus sign. Yena in the negative, okay, in the negative is representing both are in the opposite direction, which means electric field increasing na anga வந்து we can say that in the potential வந்து decrease ஆக போறேன். So let us say if I'm having a field like this, okay, இது வந்து uniform field, okay, இது வந்து uniform field தான். So if I'm just finding this point is there, this point is there, okay, we have the point A as well as B, and what I said, the field or let's say the potential will decrease in the direction of field. So I can say that the potential at B will be less than that of potential at A. ஏனா இது வந்து direction, in the direction of field தான். So அதனால எப்பவுமே the potential at A will be greater than potential at B தான். Okay, always வந்து in the direction of field இல்ல, it will be always reduces. புரிஞ்சுதாடா? Everybody understood? Yes or no? Yes or no? And now we can just go for another topic, அது வந்து equipotential surface. அதுக்கப்புறம் we can just go for the question practice. Okay, then if you are feeling hungry na, we can also go for a break as well. Okay, so இப்போ வந்து we were discussing about the what? Yes, equipotential surface. Okay, equipotential surface. So when I'm talking about equipotential surface na, அந்த termல அந்த sentenceல இருக்கு அதோட meaning. Equipotential na, இப்போ வந்து இந்த surface எடுத்தேனா அதுல வந்து all the points, okay, all the points will have the same potential. Okay, and the surface la same potential இருக்கும். If you are taking any of the point na, and the potential வந்து same ஆக போகுது. Let us say for example, I am taking a positive charge. Okay, I am taking a sphere. Okay, I am taking a sphere which is having equal radius. So which means இப்போ வந்து இந்த ஒரு positive charge இருக்குல்ல, அதுல வந்து I am just considering a 3-dimensional sphere I am considering. So அந்த sphereல ஏதாச்சும் point if you are taking na, அந்த potential வந்து same ஆ இருக்கும். Okay, and the sphere la same, I mean if you are taking any point from here and the sphere la irukra points ku vanda same potential ah irukum. Purinjudada, same potential ah irukum. Now let us say if I'm just taking a sheet. Okay, ipo vanda I have a sheet, so indha madri da field varum, correct ah? So I can say that again I will be getting equipotential surface, a plane I will be get it as an equipotential surface. So in the point la, if I am finding the potential na, adukku vanda I will be get it as same everywhere. Purinjuda. Ipo vanda I have a wire. Okay, so adu vanda positively charged da. So adanal if I am just considering a cylinder. Okay, if I'm just considering a cylinder na, in the cylinder la irukra ovvaru point kume same potential ah irukum. Okay, in the cylinder la irukra ovvaru point kume we will be getting the same potential. Purinjudada? Any of this curved surface, if you are just checking on the potential, adu vanda same aga pore, and the cylindrical surface complete ah vanda same aga pore. So this is what I said, for a point charge ku vanda எப்பவுமே spherical da, in the equipotential surface vanda எப்பவுமே spherical da irukum. Line charge ku vandu eppovume it will be cylindrical, as well as a conducting sheet or what is a non-conducting sheet kaga we can say that eppovume adu vandu parallel planes. Like this way we will be getting parallel planes. Purinjudada? Everybody understood? So idudha vandu point charge, and idudha vandu namma sheet. Idhula vandu parallel plates da. Okay, we will be getting inga varumbodhu sphere da equipotential surface. Idudha vanda line charge. Okay, so idhula paakumbodhu you can see that cylindrical da idoda equipotential surface. Everybody understood? Yes or no? Thank you so much. Okay, so idudha vanda basic ana thing. Now just understand, idudha vanda nama positive charge. As I mentioned, idudha vandu nama equipotential surface, correct ah? Idudha vandu nama equipotential surface. Ipo vandu if I am representing the field lines like this, we know that for a positive charge these field lines will be radially outward da, correct ah? So eppavume in the field lines will make 90 degree with the equipotential surface. So we can say that equipotential surface always perpendicular to the field lines. Idu vandu again important ana point. Next vandu, let us say if I am taking a charge from point A to B, which means I am taking the charge from point A to B, which is on the same equipotential surface. Okay va, purinjuda? So now I am taking the charge from point A to B, and in the A and B vanda same surface la tha irukke. Okay, same equipotential surface da. Appadina the work done will be coming as 0. Yeah, work done na we know Q into delta V da. So in the case la VF minus VI da. So in the case la varumbodhu same potential irukum. So we will be get it as the work done will be 0. So equipotential related we have discussed a few important things. Ellame vandu important da. Each and every point which I have mentioned vandu important da. So first vandu as I mentioned, equipotential surface na and the surface la irukra ovvaru point kume same potential ah irukum. Correct ah? Second point vandu in the equipotential surface for a point charge vandu spherical ah irukum, linear charge ku vandu cylindrical ah irukum, and sheet ku vandu parallel planes ah irukum. Okay va? Next vandu we know that when we are just taking the field lines and equipotential surface na, always it will be perpendicular to each other, and if you are bringing one charge from one point to another point in the same equipotential surface na, adoda work done vandu 0 aga pore. So all the equations, everything whatever I have written over here, you can just write. Also, you can just mention this equipotential surface will never intersect. Okay, it will never intersect. Adu kuda important ana point irukke. And also you can just note this as well. Let us say I have a point. Okay, I have an equipotential surface over here. I have another equipotential surface over here. So let us say I'm just calling this as 1, this as 2. Okay, wow. So now my question is which surface will be having the highest potential, V1 or V2, which means V1 or V2 relation that I should get. Now my question is, in the surface, idha vandu number 1, idha vandu number second equipotential surface. So in the first equipotential surface illa second equipotential surface illa potential vandu adhigama irukum. Can you give me the answer? Can you give me the answer quickly? Quickly you can give me the answer. So in the two surface irukku, first one and second one, idhula vandu which one will be having the largest potential? Based on the previous case, we have discussed something, some important term, I have written it clearly, correct? So adhula vandu paakumbodhu, we know that in the potential decreases in the direction of field, correct? In the direction of field. அப்படினா field oda direction வந்து இப்படி தான் வர போறே. So அதனால I can say that V1 will be greater than, very good evening star. Okay, so it will be always V1 will be greater than that of V2. So இப்போ வந்து important ஆன each and every terms வந்து you can just mark it right now and you can just note it down. Okay, everybody done? So idha vandu innekku vandu we have studied. Okay, also we have studied about the relation this E is equal to minus dV by dr. Appadina to find V or delta V, you can go for integral E dot dr as well. So you can also now note this equation as well. Okay, so now let us just summarize whatever we have studied right now, then we can go for the problem solving. Okay, so we were started with the potential energy. Potential energy na the work done against the electrostatic force bringing a charge from infinity to a point which is at a distance r from the capital Q. இப்போ வந்து அந்த charge unit test charge na it will be coming as the unit test charge na it will be coming as nothing but potential. So now the thing is like the potential energy per charge, okay, or otherwise the work done by external divided by the charge, or let's say minus work done by electrostatic force divided by charge. இதெல்லாமே வந்து nothing but our potential. And in the potential வந்து it is a scalar quantity da. Okay, this is a scalar quantity and idoda unit vandu joule per coulomb, or let's say we can say that is nothing but volt. Okay, and then we have studied about the potential difference. Potential difference na when you are taking one charge from a point A to B, so the work done required for bringing the charge from A to B, that is what nothing but VB minus VA. What is this? The work done taking required for taking a charge from taking a unit test charge. Okay, unit test charge from A to B in the VB minus VA. Correct? Adukapram we have studied some of the important potentials due to different shapes. For ring it will be KQ by, it will be coming as KQ divided by root of R square plus X square. And also we have discussed about the the spherical shell as well as solid sphere. So everything you have to mention, everything you have to study, because in the chapter la irundhu direct formula apply pandra type questions will come. Okay, adnala I'm telling you. So these are the very important thing. Adukapram we have studied about the we have studied about which one? We were discussed about the equipotential surface. Equipotential surface la we have discussed same potential arukum on the surface la, and work done to bring a charge in the same surface vanda zero aga pore. And always equipotential surface and field lines vanda eppavume it will be coming perpendicular, and also we can say that this will be okay, this will be always the potential vanda it will always decrease in the direction of field. So these are the things we have studied right now. So now let us move on to the question part. Okay, first question, write the potential energy of the following system. Write the potential energy of the following system. Can you just write it? Can you write the answer? I'll give you some time. We already discussed about this thing. So now you can just find it. Give me the answer quickly for this question. Potential energy of the following system. So in the case of first one, you can just find out how many pairs it will come. Okay, how many pairs it will come. Adikapra you can find the individual potential. Negative charge irundiruchuna, you have to keep the negative sign. Illana it is going to be in trouble. Okay. I'll give you some time. You can just go for this timer. Calculate it. 1 minute podumda. When I'm giving more time. So in the question, what we will do first one, the 4 charges da irukke. So adanala we can go for n into n minus 1 divided by 2. So 4 into 3 by 2. So which will be coming as 6 number of pairs should be there. So first on the Bakampod, I'm going for this 2. Okay, I'm going for this 2. So this will be coming as k into minus q will be plus q square divided by r. Okay, divided by r. Next one is this one. Okay, so that will be again minus, it will come. Okay, yeah, we know that there will be a minus sign and another one is plus. So k q square divided by r. Again plus q da. So plus k q square divided by r. Again plus q minus q. So k q square divided by r. So anga kuda we have to keep the minus sign. Next one the paakumbodhu we have 2 charges, or let's say we have 2 charges which is at a distance. So first one we should find the distance. So on the distance idu r, Pythagoras theorem use பண்ணும்போது you will be getting this as root 2r. Okay, and in the distance kuda same irka pore. So now I can just write minus, yena inga minus da k q square divided by root 2r. Okay, again we have one more. Anga kuda minus k q square divided by root 2r da varapore. Correct? So now what will happen? In the kq square, minus kq square will be get cancelled. This will be get cancelled, and finally we will be having minus kq square 2 times divided by root 2r. So this will be coming as minus root 2 kq square divided by r da namma answer varadu. Purinchudada? Everybody understood, yes or no? So you will be getting option C as the right answer. Understood, yes or no? Yes or no, everybody? Okay. So now we are moving on to the next question. find the charge Q such that the potential VA which is equal to 0. We need to know the potential. So, adanala I'm just giving you some time. So, you can just find it out. What is the total potential at A? So, in the potential at A, na, in the 3 coulomb, in the Q, in the 3 coulomb, ellame vanda, they will be exerting some potential over there, and you will be adding, because yena idu vanda scalar quantity da. So simpler you can just add it. So find the potential due to 3 coulomb, find the potential due to Q charge, find the potential due to this 3 coulomb charge as well. Add it up, and that while you are adding, you will be get it as 0. Now adula irukra ore oru unknown vanda in the Q mattum da irukke. So now you can just go for finding the Q as well. 50 more seconds irukku, you can solve it now. Okay, so now the thing is like I'm going to find the potential due to 3 coulomb, potential due to Q plus the potential due to 3 coulomb, which will be coming as 0. So ipo vandu idu paakumbodhu we can say that K into Q vandu 3 da divided by distance vandu 5, and inga kuda K Q divided by distance vandu 4, plus K into 3 divided by again 5, which will be coming as 0. So now the thing is like you can just take the K outside. So what you will be getting? What you will be getting? Yes, Yashwant. Okay. So ipo vandu paakumbodhu you can just see that if you are taking K outside na, 3 by 5 plus Q by 4 plus again 3 by 5. Okay. So idudha vandu what you are going to get it, and you can just equate it to 0. Then you will be, this K will be gone, 3 by 4 irukum, Q by 4 irukum, plus 3 by 5 irukum. Now you can just go for finding the answer for it. Okay. Now it is your turn to find Q. You will be getting 3 by 5 plus Q by 4 plus 3 by 5, which is equal to 0. Yes, Yashwant, ask please. So, idu vandu paakumbodhu you will be getting this 3 by 5, this will be coming as 6 by 5 plus Q by 4, which is equal to 0. So, 6 by 5 into 4, which is equal to Q. So, you will be getting minus 24 divided by 5, which will be coming as Q. So, which means option A is going to be the right answer. Purinjidada, very simple ana concept. We have just find the total potential experienced at that point VA, and it is mentioned in the question itself, and the total potential vandu 0 da. So I have written all the potential and I have equated it with 0. And ella time lume K irukku, so I kept K outside, and I can just write it as 3 by 5 plus Q by 4 plus 3 by 5 vandu equal to 0. From here I have written 6 by 4 plus Q by 4, which is equal to 0. Adukapram we will be getting the Q value as the minus 24 divided by 5. Okay, simple on a question. I have already I have discussed, and the total potential at the point A vandu 0, adu vandu given data da. Correct? So adukapram what we are doing, we are just calculating the potential due to 3 coulomb, potential due to Q, potential due to again 3 coulomb. So potential order general equation na K Q by R da. So in the case like Q na 3, R na 5. In the case like Q na Q da distance vandu 4 da, and in the case la vandu 3 and 5 da. So you will be giving those values. Okay va? So now we are going to the next question. Okay. So in the case, what will be the total work done on moving the charge of 5 microcoulomb from 10 volt surface to 2 volt surface, then 2 volt surface to 5 volt surface, and at last 5 volt surface to 10 volt surface. Now you can just give me the answer quickly. Idoda answer vandu you can just give me quickly. Quickly you can give me the answer. So, idhula irukkiradhula potential is given. Idhula irukkiradhula potential is given on each surface. Adukapram what you need to do? You need to find the work done da you need to find. இதுக்கு வந்து அவ்வளோ you don't need to think பண்ற அளவுக்கு அந்த மாதிரி டிஃபிகல்ட்டான கொஸ்டின் கிடையாது. இந்த கான்செப்டை வந்து we already discussed about it. So what is the concept behind it? இப்போ வந்து we know that in the work done charge into delta V da. Okay, charge into final voltage divided by the initial potential. So இப்போ வந்து பார்க்கும்போது started with 10 volt and ends up with 10 volt da, which means in the delta V வந்து 0 da. So you will be getting the work done which is equal to 0. புரிஞ்சுதாடா everybody? Understood? Yes or no? So in the case in the equipotential surface oda same concept, correct? 10 volt la irundhu again 10 volt surface la vara pore. So adanal delta V vandu 0 agum, and delta V 0 na work done will also come as 0. Okay, so those are joined right now. You can just like this video, also share with your friends as well. Okay, so we have discussed about the potential and potential energy. Next we are going for the, very good Yashwat, okay, we are going for the electric dipole. Okay, so adukku munnadi we are going for a lunch break. Okay, so we will be just take a 20 minutes of break. So you can just come after 20 minutes. Okay. So let us continue with the rest of the part. Okay, so we are moving on to the electric dipole. So when I'm talking about electric dipole na ennada? Electric dipole na, it is nothing but two charges, correct? Two equal and opposite charges. So electric dipole is nothing but two charges, two equal and opposite charges separated by a small distance is nothing but the electric dipole. So idudha vandu namma electric dipole. So when I'm talking about this electric dipole na, I should introduce one more term, that is nothing but dipole moment. Okay, dipole moment. This term is actually giving you the strength of the dipole. This is actually giving you the strength of the dipole. And also idoda unit வந்து Coulomb meter da. Okay, Coulomb meter, or let's say we can say Dipole. So this is the another unit, and also this is a vector quantity, and we can just find it as Q into the distance of separation. Okay, Q into the distance of separation is nothing but, yes, hi Lakshmi, hi. Okay, so dipole moment na, it is nothing but giving you an idea about the strength of the dipole, and on the value kandupidikiradhukku we can use the equation Q into distance of separation, which means inga oru minus Q irukku, inga vandu oru plus Q irukku. So in the distance illaya, usually vandu we will represent it as 12. Yena vandu, while we are finding the electric field due to dipole and all, we should take the distance from the center. So if we are taking L na, that distance will become L by 2. Calculations vandu konjam difficult aga pore. So right now, even if you are taking 12, the distance from the center will be coming as L. Calculation vandu avlo tough agadu. Purinjida? So right now we have minus Q, we have plus Q, and these two are separated by a distance which is nothing but 2L na. Illana generally vandu you can just study this equation, the charge into distance of separation. So there won't be much confusions like 2L, 2 times into length of, separation between them, or that kind of confusions won't be there. Thus 2L, or let's say whatever you're representing 2A, that is nothing but, when it comes to the equation, you should only use the distance, the charge and the two charges kulla irukra distance of separation mattum da you should know. So electric dipole na, two charges separated by a small distance da. Dipole strength na, that is given by dipole moment, adu vandu oru vector quantity, and adoda direction vandu always from the negative to the positive charge da. Always it will be coming from the negative charge to the positive charge da. Now இங்க வந்து ஒரு டைபோல் இருக்கு, மைனஸ் Q இருக்கு, பிளஸ் Q இருக்கு. ஓகேவா? சோ இங்க இருக்குதுல ஃபர்ஸ்ட் வந்து you should know the electric field due to any, this dipole at any point. Okay, இது வந்து ஜெனரலா இருக்கிற equation, any point. So இந்த ஒரே ஒரு equation போதும், you can just find axial as well as equatorial. ஓகேவா? So இதோட equation வந்து Kp divided by r cube root of, we will be getting root of 3 cos square theta plus 1. இதுதான் வந்து ஜெனரலா இருக்கிற equation. புரிஞ்சுதா? The field at any point due to the electric dipole will be coming as Kp by r cube root of 3 cos square theta plus 1 will be the answer. Now the thing is like, this is the point P. Okay, so inga da namma angle theta. Okay, so right now we will be having the two electric field, and the net electric field we will be get it here, which will be making an angle alpha. Appadina, again you should study one more relation connecting this angle, tan alpha, which is equal to tan theta by 2. In the derivations ellame vandu exam ku thevai illa, NEET exam la vandu specific you need to study the formulas. So in the relation mattum you have to study the field at any point due to a electric dipole will be coming as Kp by r cube root of 3 cos square theta plus 1, and tan alpha will be equal to tan theta by 2. Another equation, the potential due to any point will be coming as Kp cos theta divided by r square. So, this is the three equations which you have to study. Now, let us say the electric field at the axial point, in the angle, it will be coming as 0. Correct? This theta will be coming as 0. Appadina Kp by r cube root of 3 cos square theta na cos square 0 which will be 1. So 1 plus 1 you will be getting 2 kp divided by r cube. இப்போ வந்து equatorial na இந்த theta வந்து 90 degree ஆக போறே. So that will be coming as kp by r cube root of 3 cos square theta will be coming as 0. ஏனா cos square theta வந்து cos square 90 0 தான். So 0 plus 1. So you will be getting kp divided by r cube. புரிஞ்சுதா? So இந்த மாதிரி you can just find for the potential as well. So potential at the axial point will be coming as kp cos theta will be coming as cos 0. So kp by r square and v equatorial will be coming as 0. ஏனா kp cos 90 will be coming as 0. புரிஞ்சுதாடா? Yes or no? So in the equations எல்லாமே வந்து important. Generally you should study this three equations which will help you to solve any of the problem which is coming in the electric dipole. புரிஞ்சுதாடா? Everybody understood? Yes or no? Everybody tell me you guys understood or what? You guys have to tell me. Electric dipole in the three equations mattum you have to study. The rest of the cases you can just give the angle and you will be getting the answer. Purinjida? Yes or no? Everybody tell me. Everybody understood? So we understood about the electric dipole. Now the thing is like, let us say we have a uniform field. Okay, we have a uniform field. In the uniform field, I'm going to place a dipole. Okay, so inga irukkiradhu minus q charge da, inga irukkiradhu plus q charge da. So in the field nala definite vandu these two charges will experience a force. Correct? So in the plus q will also experience a force and minus q will also experience a force. So plus q garada, it will be experience a force in this direction which is equal to QE. Magnitude one the QE da. Since it is a uniform electric field, if I'm just considering this point na, in the minus q will experience a force in this direction which is also equal to QE, which means magnitude one the same da. Okay, magnitude the same da and direction the exact opposite. So the dipole in uniform electric field. Okay, uniform electric field, we can say that the net force will be coming as 0. The net force will be coming as 0. First, that is the analysis. Next one, we should know the torque. Okay, so idinala the net force is 0, which is indicating there is no translatory motion. Now the thing is like in the dipole ipdi irukke, and now the thing is like it is experiencing a what is in the direction la QE experience pandra, in the direction la QE experience pandra. So there is a possibility of rotation. Okay, so appadina in the torque order relation, na R cross F da, correct? R cross F da. So in the case like F na QE da. Now the thing is like R, the perpendicular distance. So on the perpendicular distance we will be get it like this. This is the perpendicular distance. So if you know this angle theta, okay, in the dipole and field making an angle theta na, definitely we can say that sin theta will be coming as this side, let me just write it as x, divided by the distance of separation, which means 2L in this case. Okay, so இது dipole da, the distance 2L da. So opposite side by this one will be giving you 2L sin theta, which is equal to x. In the x da, whatever we are requesting or whatever we need the perpendicular distance, now I'm going to place it here 2L sin theta into QE. So when I'm just going for Q into 2L na, which means that is nothing but the dipole moment. So I'll be getting PE sin theta. So I can say that in the torque which is equal to P cross E the answer. This again another important relation. Okay, ask Vijay, no issues. Okay, so in the torque it will be equal to P cross E, which means the dipole moment into the electric field in the torque value. So very simple, when we are placing an electric dipole in a uniform electric field, it will be experiencing a force which is nothing but QE. Okay, a charged particle is placed in an electric field. If the velocity is initially perpendicular, okay, what is the nature of its trajectory? Parabola. Okay, if it is perpendicular, it will be experiencing parabolic. The path will be parabolic. Okay, so right now we were discussing about the torque, and torque will be coming as P cross E, which means that the magnitude the PE sin theta. So whenever we are placing a dipole in a uniform electric field, the net force experienced by that will be coming as 0, and if the net force is 0, there is no translatory motion, and it will experience a torque, and the torque equal to PE sin theta, or else we can say it will be P cross E adoda value, and also we can say that due to this torque, it will go for a rotational motion. Now the thing is, like the same dipole, we are keeping in non-uniform field. Okay, non-uniform field. So appadina what will happen? Non-uniform field definitely it can be, this is the dipole, here we have the plus Q, here we have the minus Q. So definitely there is a possibility, okay, there is a possibility that the net force can be same, which means in the point field and in the point field the same, force can be 0. So I can say that force, the net force, can be 0, cannot be 0. So there is no, we cannot use the net force must be 0. Yeah, there is a possibility, okay, to have 0, to not to have 0 as well. I hope you got it. புரிஞ்சுதா? யூனிஃபார்ம் ஃபீல்டுனா நெட் ஃபோர்ஸ் கன்ஃபார்மா 0 தான். Okay, the net force கன்ஃபார்மா 0 தான். ஆனா when it comes to non-uniform, the net force will be there. Okay, ஆனா I cannot say that there will be the net force not equal to 0 all the time. It can be 0 also, which means in the point field and in the point field same ஆனா, okay, we can say and the net force kuda it is going to be same. Okay, appadina it will be, the net force will be coming as 0. So adinala when it comes to non-uniform we cannot simply say net force is equal to not equal to 0. And the madri we cannot say. We can say that total will be 0, and here it can be not equal to 0 as well. புரிஞ்சுதாடா? So this is what we should understand, and in the non-uniform field torque kuda irukku. Next we are going to discuss about the work done. Okay, work done definitely we know that work done equation enna, it is nothing but tau d theta da. So appadina work done, to find work done we can go for PE sin theta d theta. So idudha the equation. So while we are integrating from theta 1 to theta 2, we can say PE the constant da, we will be getting minus cos theta from theta 1 to theta 2. So work done will be PE into, and I'm just taking the minus sign out, so cos theta 2 minus cos theta 1. So if I'm just multiplying this minus sign inside, I will be getting PE cos theta 1 minus cos theta 2. So this is the work done when we are making, or let's say when the dipole is rotating for theta 1 from theta 1 to theta 2, the work done will be coming as PE cos theta 1 minus cos theta 2. Purinjidada everybody? Everybody understood? So this is what the work done. Now we understood about the work done. Next is nothing but we know the potential energy. Okay, potential energy in the work done the potential energy store பண்ணிட்டு இருக்கேன், and we know there should be a reference point also, and the reference point is nothing but theta is equal to 90 degree da, which means in the case in the theta 1 90 degree we are going to take it. அப்படினா in the potential energy PE into minus cos theta it will come, which means we can write minus PE cos theta, or let us say minus P dot E in the potential energy. So work done will be coming as PE cos theta 1 minus cos theta 2. When it comes to the potential energy, now it will be coming as minus P dot E. So appadina, we should find the potential energy. We got it as P dot E, or let's say we got it as minus PE cos theta. Appadina, when theta is equal to 90 degree, you will be getting U as 0. When theta is equal to 0 degree, you will be getting minus PE. When theta is equal to 180 degree, you will be getting U is equal to PE. So, this is the important few things which you should study. When theta is equal to 0, this will become cos theta, cos 0, 1 it will come. So, you will be getting minus PE. When theta is equal to 180 degree, you will be getting the potential energy to the value which is PE. Which means this is the maximum potential energy and this is the minimum potential energy and this is our reference point. Now I can just say that this will be the most stable state, which means when the dipole moment as well as electric field are in the same direction, okay, P and E are parallel, okay, the dipole moment oda direction and electric field oda direction vandu same agumbodhu illana idu vandu parallel agumbodhu, we can say that anga irukkiradhu minimum potential energy da, yena adoda magnitude vandu minus PE da, okay, minimum value da. So minimum value na I can say that eppavume minimum potential energy il irukkiradhu da most stable. So when it is aligned, which means in the dipole aligned in the direction of electric field na adu the stable arkum. And when it comes to theta is equal to 180 degree, ange irukkiradhu maximum potential energy, which means adu vandu PE da. So in the point I can say that idu vandu unstable da, okay, idu vandu unstable da, which means in the field and dipole moment vandu exactly opposite direction la irukku. So those who have joined right now, you can just like this video, share with your friends, as well as you can just subscribe the channel as well. Okay va? So maximum potential energy, and we can say that on the point la unstable da, okay, that is nothing but unstable. It is representing unstable. Purinjada everybody understood? Yes or no? Yes or no? Now we are going for angular HSM. Okay, angular SHM da we are going for it. So right now we know that torque is equal to PE sin theta da. Okay, so if you are just giving a very small angle, if you are just, if you are just taking them into a very small angle, appadina அந்த momentல it will be going for oscillation. Okay, when it is aligned with the electric field, and now we are just making to some small d theta angle, or let's say it's a very small angle, appadina this will start oscillate with the mean position, or let's say it's a equilibrium position. Appadina I just wanted to know what is the time period of that. Okay, adukkaga I'm going to find it. So in the theta is very small da. Okay, in the theta very small da. If theta is very small, I can just rewrite this as PE theta. Okay, I can just write it as PE theta. Now torque oda equation, rotational motion chapter la irundha torque ku we have studied one more equation, that is nothing but I alpha, which is equal to P theta. Alpha na angular acceleration da. So I can just say that this is nothing but d square theta divided by dt square, which is equal to PE theta. Okay, so this is the equation. Now I'm just making d square theta divided by dt square over this side. So I'll be getting PE by I into theta as this one. Now you know the simple harmonic equation. Adoda equation enna d square x by dt square, which is equal to omega square x. Okay, this is the equation. Now if you are comparing this two equation, you will be getting omega square, which is equal to PE by I. Correct? Instead of x, we have this theta. So adanale omega square will be coming as PE by I. So appadina omega root of PE by I da. Okay, what you got? Omega, which is equal to root of PE by I. Now the thing is like, omega, T na 2 pi by omega da. Okay, so I can just write 2 pi into root of PE by I, which means I can go for 2 pi into I divided by P as the time period, which means if you are just considering the angular SHM, when a dipole is suspended in a uniform electric field, it will align itself parallel to the field. Now, if you are going for a small angular displacement theta, then it will oscillate about its equilibrium position, and we will be getting the time period as 2 pi into root of I divided by PE. Again, very, very, very important concept. இது வந்து separate question கேட்கலாம். Okay. புரிஞ்சுதா? Everybody, yes or no? Understood? Everybody understood, yes or no? So next one, we are going for electrostatics in conductors. Okay, so idhula irukkiradhu important ana konjam points da, adu mattum you have to study. So let us say the electric field just outside the conducting surface or conductor, okay, that will be coming as sigma by epsilon naught. We can use the Gauss's law and we will be getting that value is equal to sigma by epsilon naught. So it is same like how we will be doing for the sheet. Okay, but ana in the sheet la you can just see two surface irukku. Conductor la inside one the field 0 da, so outside mattum da we need to consider, even if we are considering the Gaussian surface inside also adula irukkiradhu vandu 0 da, so there will be only a field which is coming out. So we can say that adu vandu sigma by 2 sigma by epsilon naught da. Next vandu in the we know that in the conductors la we can just see that the charges will spread over the surface, correct ah, and the surface la idu vandu spread agum. So and the madri, if let's say if in the conductor ku vandu positive charge na, positive charges vandu in the surface la it will orient, or let's say it will be just accumulate on the surface. So appa vandu anga vandu oru pressure irukum illaya, positive and the repulsion irukum, illana negative charge na negative and the repulsion irukum. So anga irukkiradhula oru pressure irukku. Okay, this charges will exert some pressure each other, correct ah, there will be some pressure each other. So on the pressure oda value vandu sigma square by 2 epsilon naught. புரிஞ்சுதா? So on the pressure oda value vandu it is nothing but sigma square divided by 2 epsilon naught. Sigma na it is nothing but the surface charge density da. So this is also another important one. And we know that the electric field inside the conductor will be 0 da. Adanale the potential inside the conductor vandu constant, and it will be equal to same as the surface. Okay va? So electric field inside a conductor vandu 0 da, adula irukra potential inside point la irukra potential vandu same da, and that value will be same as the surface. Purinjidada? So these are the important points. Next vandu electric field lines cannot penetrate to inside the conductor. Okay, in the conductor order, it cannot penetrate through the conductor. And another important point is the electric field, as we said, it will be 0, and the electric field lines will be always perpendicular to the metal surface. Okay, it will be always coming as perpendicular to the metal surface. And always we can say that in the charges will always align on the surface. Okay, it will always align at the surface of the conductor. Okay, and in the conductor la we know there are more free electrons. Ipo vandu neenga vandu in the conductor external electric field la introduce pannalum, what will happen, in the free electrons will align and it will create an electric field in the opposite direction, and it will cancel the electric field. Okay, so these are the important points which is coming under the electrostatics of conductors. Okay, Next வந்து another topic that is nothing but sharing of charges. Okay, again another topic which is multiple times. You can just see multiple times in the question கேட்டுட்டு. So we have two conducting holospherical shell. அது வந்து we are just connecting with the conducting wire. Okay, இதோட radius வந்து R1 தான், இதோட radius வந்து R2 தான். So now we are connected with the conducting wire. So we know that definitely what will happen? The charge flow will happen. Okay, charge flow will happen. And definitely we know that if this charge flow is happening now, definitely we could say the potential, this will happen till the potential remains the same. Okay, till the potential become same. Appadina we can say K into Q1 divided by R1, which is equal to K Q2 divided by R2. So now I can say this Q1 will be equal to Q2 R1 divided by R2. இதுதா வந்து first analysis. After after connecting the charged conducting wire, what will happen? The charge flow will happen, and the charge flow will happen till the potential remains same. Okay, and the first potential, holos conductor oda potential வந்து equal to second ஆகற வரைக்கும் இந்த charge flow will happen. So adila irundhu I got to know Q1 na it is nothing but Q2 divided by R1 divided by R2 da. So now the thing is like, initially according to charge conservation, total charge initially வந்து இதுக்குள்ள Q1 charge தான், இதுக்குள்ள Q2 charge தான், and அதுக்கப்புறம் what happened? In the charges become Q1 plus Q2. Okay, after charging, after connecting the conducting wire, the charge flow should happen till the potential remains same. Correct? So அதுக்காக I can say after this conducting wire, each body gained a charge which is Q1 and Q2. Correct இல்லையா? So now Q1 plus Q2 which is equal to small q1 plus Q2. So right now the thing is like I know what is Q1 plus Q2. Okay, now I'm going to replace Q1. What is Q1? R1 by R2 Q2. Again we have a Q2 over here. Now I'm just taking Q2 outside. So what I'll be getting? R1 by R2 plus 1 da in the Q2. So initially வந்து ஒவ்வொரு பாடியில இருக்கிற charge வந்து we know it, and now the thing is like we got it, this Q1 plus Q2 which is equal to Q2 divided by R1 by R2 plus 1. So now I can write Q1 plus Q2 divided by R1 by R2 plus 1 will give me this Q2. Once you get it Q2, you can substitute and you can find Q1. Okay, so idhula use பண்ற concept என்னன்னா conservation of charges da. Okay, conservation of charges da we are using here. புரிஞ்சுதாடா? Everybody understood? So simple ஆன concept. First வந்து we know that we have two spheres. Okay, அதுல இருக்கிற charge வந்து initially the charge வந்து Q1 and இங்க இருக்கிறது Q2 da. After this the charges become Q1 and Q2. We know according to conservation of charge, initially எவ்வளோ charge இருந்த Q1 plus Q2 தான். After using this conducting wire also, அந்த charge வந்து Q1 plus Q2 ஆகணும். கரெக்டா? So அப்படினா I will be getting Q1 plus Q2 which is equal to Q1 plus Q2. Another thing is like we know that this charge flow will happen till the potential remains same, and அங்க இருந்து I got the expression for Q1 and I have substituted Q1 over here instead of in terms of Q2. அதுக்கப்புறம் I found what is Q2. So இதுதான் வந்து the thing which you should do when it comes to sharing of charges. புரிஞ்சுதாடா? Everybody understood? Yes or no? Yes or no? Please let me know. Everybody? இந்த கான்செப்ட் கூட இம்பார்ட்டன்ட் தான். நெக்ஸ்ட் வந்து we are going to discuss about the concentric spheres, which means we have a holosphere over here and we have another holosphere over here. Okay, இந்த two spheres க்கு we know இதோட radius வந்து R1 தான், இதோட radius வந்து R2 தான். கரெக்ட்டா? Okay, so இப்போ வந்து my question is find the potential at the surface of the first sphere. இதுதான் வந்து நம்ம first sphere. அந்த first sphereல surfaceல இருக்கிற potential என்ன? Okay வா, அதுதான் வந்து we should find it. இதுல இருக்கிற charge q1, இதுல இருக்கிற charge வந்து q2 தான். அப்படினா I can say that, just imagine இந்த sphere மட்டும் தான் இருக்கு. Okay, இதோட radius வந்து r1, இதோட charge வந்து q1. அப்படினா what is supposed to be the potential? What is supposed to be the potential? இப்போ வந்து if I'm just taking a sphere, okay, if I'm taking a sphere, அந்த sphere ஓட radius வந்து r1 தான். அப்படினா அந்த I mean there is only one sphere. அப்படினா அந்த surfaceல இருக்கிற potential வந்து we already studied, it is nothing but kq1 divided by r1. Okay வா? next வந்து I have another sphere and இதோட radius வந்து r2, இதுல இருக்கிற charge வந்து q2. அப்படினா I just wanted to know இந்த பாயிண்ட்ல இருக்கிற potential, which means what is the potential at the surface of the inside the hollow sphere. புரிஞ்சுதா? question புரிஞ்சுதா? so இந்த கேஸ்ல q2 charge தான் இருக்கு. இந்த q2 charge யூஸ் பண்ணி, or let's say inside the hollow sphere, what is supposed to be the potential? inside இல்லையா, hollow sphere இல்லையா, so அதனால I can say that inside will be equal to the potential at the surface, so I can say kq2 divided by r2. now coming back to this, when I'm just talking about this point A, okay, when I'm talking about this point A, what is happening? For this sphere, it is on the surface, which means it will be having a potential that is equal to kq1 divided by r1. Now for this one, this point, the second sphere is having, considering this point as a point which is coming inside. அப்படினா அதோட potential வந்து kq2 divided by r2. புரிஞ்சுதாடா everybody? Yes or no? Understood? Yes or no? Yes or no? Please let me know. Okay, so இதுதான் வந்து சிம்பிளான கான்செப்ட். கான்சென்ட்ரிக் ஸ்பியர்ஸ் வரும்போது you should consider in the first sphereல அந்த பாயிண்ட் எங்க இருக்கு. Okay, now I'm going to give you another question. இதுதான் வந்து first sphere, இதுதான் வந்து நம்ம second sphere, and இதோட charge வந்து q1, radius வந்து r1, இதோட charge q2, இதோட radius வந்து r2. அப்படினா I just wanted to know the potential at this point, which is nothing but point A. அப்படினா again for the small sphere it is coming inside. அப்படினா அந்த potential வந்து kq1 divided by r1, ஏனா அது வந்து surfaceல இருக்கிற point, கரெக்ட்டா? and for the bigger one, again that is inside point தான். so அதனால அது contribute பண்ற potential வந்து kq2 divided by r2. so அதனால the potential at A will be kq1 divided by r1 plus kq2 divided by r2. Okay, so now again we have two spheres. இதோட radius வந்து r1, charge வந்து q1, இதோட radius வந்து r2, charge வந்து q2. now the point is on the surface of the second sphere, which means now வந்து I'm taking a point over here B. okay, now my question is, what is the potential at B? okay, what is the potential at B? so அதுக்காக first time considering the small sphere. okay, இதோட radius வந்து r1 தான், and in the point B is actually at a distance r2. கரெக்ட்டா? ஏனா இது வந்து on the surface of the second sphere தான். so அதனால I can say that from the small sphere it is at a distance r2 from the center. correct இல்லையா? so now can you just tell me what is going to be the potential? okay, in the point, just forget about the second sphere. now my focus is only this small sphere and the point is B. அப்படினா generally we have studied about the hollow sphere, right? now you guys have to tell me what is the potential at B due to this small sphere. அதுக்காக we were using outside. okay, potential outside na we will be using kq by r. கரெக்ட்டா? so இதுல இருக்கிறது k, charge வந்து q1, and the distance small r வந்து இந்த கேஸ்ல வந்து it is coming as r2. okay, இந்த கேஸ்ல small r வந்து equal to r2 தான். ஏனா அந்த point B இருக்கிறது வந்து second sphere surfaceல தான். புரிஞ்சுதா? so now this is what is happening. now for the bigger sphere. okay, now for the bigger sphere. ஸோ இதில் இருக்கிறது வந்து R2 தான், சார்ஜ் வந்து Q2 தான், சர்ஃபேஸில் தான் இந்த பாயிண்ட் இருக்கு. அப்படின்னா இந்த பொட்டென்ஷியல் என்ன ஆக போறேன்டா, இட் வில் பி நத்திங் பட் சர்ஃபேஸில் இருக்கல, ஸோ இட் வில் பி நத்திங் பட் KQ2 divided by R2. Now the potential will be coming as due to the contribution from the small one, which is KQ1 divided by R2 plus இங்க இருக்கிறது KQ2 divided by R2. புரிஞ்சுதாடா? everybody understood? Yes or no? Please let me know in the chat box. இந்த கான்செப்ட் வந்து அவ்வளோ இம்பார்ட்டன்ட், அதனால தான் I'm telling you. இந்த கான்செப்ட் அவ்வளோ இம்பார்ட்டன்ட். So I'll be giving you one more case. Now you guys have to give me the answer. Okay? Again, we have one sphere over here. We have another sphere over here. And this is what R1, charge வந்து Q1. இது வந்து R2, charge வந்து Q2. Now I just wanted to know the field at this point. Okay, sorry, potential at this point. Let me just call it as C. In the distance வந்து R தான். Now can you give me the answer? Now can you give me the answer? First வந்து இந்த small sphere நால what is going to be the potential? What is going to be the potential? Outside the body தானா? So KQ1 divided by the distance வந்து R. Second surface நால இந்த for the second sphere also இந்த point வந்து outside தான். So I can go for KQ2 divided by R. So VC வந்து V1 plus V2 தான். So we will be getting KQ1 by R1, sorry R plus KQ2 by R. புரிஞ்சுதாட everybody? Yes or no? Now let us move on to, let us go for solving some questions. நீங்க ரெடியா? Ready now? Give me a heart in the chat box quickly. Quickly, you can give me a heart in the chat box. So in the concept வந்து அவ்வளோ important. So in the case we have to find the dipole moment. Okay va? We need to find the dipole moment. So in the dipole moment பார்க்கும்போது you can just see that plus Q இருக்கு minus 3Q இருக்கு. கரெக்டா? plus Q இருக்கு minus 3Q இருக்கு. So what I can do, இங்க இருக்கிறது plus Q. So I'm just taking plus Q. இங்க இருந்து I'm just taking a minus Q. So இப்போ வந்து I got a dipole over here and அதோட direction வந்து இப்படி தான் இருக்கும். கரெக்டா? So இங்க இருக்கிறது minus 2Q தான். left இருக்கிறது minus 2Q. இங்க இருந்து I'm taking a plus 2Q also. So இப்போ வந்து again I'm getting the dipole like this. So இங்க இருந்து I have taken a plus 2Q. So again plus 2Q is there. Minus 2Q is also there. அப்படினா again I'm getting a dipole over here. Which means if I'm just marking all the dipoles now, what I will be getting guys? So downwards I have 1. Okay. Let me call it as P. And upward I'm having 2P. And towards this direction again I'm having 2P. So இங்க இருந்து I will be getting P and I will be getting 2P from here, which is mutually perpendicular. Now as vectors you can deal and you can find the answer. Okay. So P is nothing but Q into the distance of separation da. So we have P and 2P. So we can just say that the net dipole moment will be coming as root of P1 square plus P2 square, which means root of P square plus 2P the whole square, which means root of 5P square, which means root 5P. So in the P வந்து nothing but Q into A da. So we will be getting root 5QA as the answer. புரிஞ்சுதாடா? Everybody understood? Yes or no? Yes or no, everybody? So we have to solve the questions which is coming in the dipole part. Okay. Now let us move on to the next question. 2 point charges irukku plus or minus 3.2 into 10 to the power minus 6 coulomb are separated by a distance 2.4 into 10 to the power minus 10 with each other. Find the electric potential due to the dipole at a point P, which is at a distance 3 cm from the center of the dipole. The position vector of P with respect to center of the dipole makes an angle 30 degree with the dipole. So potential order equation வந்து you know that is nothing but Kp cos theta divided by R square da. K value வந்து 9 into 10 to the power 9. P is coming as the charge is given 3.2 into 10 to the power minus 6. Distance is given as 2.4 into 10 to the power minus 10. And cos theta divided by R in the 3 centimeter. So 3 into 10 to the power minus 2 the whole square. Now you can find it. You can find the answer right now. Just substitute the values and you will be getting the answer. So what is going to be the answer? As I mentioned, 9 into 10 to the power 9 into 3.2 into 10 to the power minus 6 into 2.4 into 10 to the power minus 10 into cos 30, which will be root 3 by 2, divided by 3 into 10 to the power minus 2 the whole square. So after solving this, you are going to get option B as the right answer. Okay, so idavanta dipole we have studied. Now we have another question. It's regarding from the torque part. An electric dipole with a dipole moment 4 into 10 to the power minus 9 centimeter. Dipole moment P is given 4 into 10 to the power minus 9. Theta is given as 30 degree and the electric field is given as 5 into 10 to the power 4. Calculate the magnitude of torque. Magnitude of torque, it is nothing but P is sine theta. So P is also given, E is also given, theta is also given. Now it is your turn. You can just find the value. It is live. Okay. So now you can just substitute and you can find the answer. Just substitute the value and find the answer. 4 into 10 to the power minus 9. E na 5 into 10 to the power 4. Sine 30 na 1 by 2. Now tell me the answer, everybody. I'll give you some time as well. Do the calculation. Do the calculation and get me the answer. And those who are joined right now, you can just like this video. Also share with your friends. Subscribe the channel. Definitely this channel will give you a lot of things. Yes, very good, very good, very good. So, after solving this, what you will be getting? In the 2 and this will become 2. So, you will be getting 10 into 10 to the power minus 9 plus 4. Now, it will be coming as minus 5. So, you can say that 1 into 10 to the power minus 4 Newton meter as the torque value. Okay, wow? So next, the decreasing order of potential energy. We need to know the decreasing order of potential energy. Okay. Now, can you calculate this? Potential energy will be minimum when E and P are parallel. Minimum. Okay. And maximum when these are anti-parallel. Okay. So now this two things you should take care and you are going to get the answer. So carefully observe Paniko and give me the answer. So what is going to be the answer? The maximum will be, it is anti-parallel, which means this case B. Okay. So maximum will be B and minimum will be when it is parallel, which means first one should be B and last one should be A. So you will be getting option B as the right answer. Very good, Akshay. Very good, Lakshmi. Very good, very good, very good. Okay. Now we are moving on to the next one. Okay. If a sheet is held parallel to the field, the lines coming from, these questions are anyway we have done. Okay. In the last class, flux we were discussed anyway. So now we can just move on to, yes, potential. What is the charge on inner surface after switch is closed? Okay. So in the madri questions vandena, first one you should do, I mean, we have discussed about the concentric spheres, right? So, adilirundha, what is the potential, total potential coming that you have to find. So, in the case, it is asked for what is the charge on this one, correct? So, now the first thing is like, let us say this is A, okay, this is the sphere A. So, you should find what is the total potential of experienced by this sphere on the surface, okay, surface of the sphere, what is the total potential, adu vandu find panniko. And when it is grounded, which means it is, the switch is closed na, in the potential vandu zero aga pore. So whatever you are getting, okay, whatever you are getting, the total potential, that you can equate with zero, which will give you the answer. Now you can just find the total potential, which you already know it, and then you can just go for finding the what to say, you can equate and you can find the x value. Yes, good afternoon, Sangeeta. Okay, Bharani, I remember, I'm sorry. Okay, so VA is equal to 0 da. So just before we have discussed about the concentric spheres. So on the concept use panniko, you will be getting the answer. Very good, very good. Quick, I'm getting some response. 1 minute 30 seconds irukku. First one, the total potential on the surface. Okay. So in the inner surface, we know that it is coming on the surface. So adinala we can say that it will be coming as K into Q divided by capital R. And due to the outer surface, it will be coming as K into Q divided by 2R, which will be equal to 0. Simple on a question. You just need to do this. And those who have joined right now, you can like this video, share and subscribe the channel. So, idhula vandu paakumbodhu, due to the small sphere, it will be K into X, and the charge that we need to find R plus K into Q divided by 2R, which will be coming as 0. So, Kx by R will be equal to minus Kq by 2R. So, K will be get cancelled, R will be get cancelled. You will be getting X is equal to minus Q by 2. Okay, so you will be getting option D as the answer. Very good, Akshay. Very good. Perfect. Akshaya, right? Sorry, Akshaya. Very good. Okay, so this is the answer. The first, the concentric sphere order concept mattunda inge vandu we have to use. The rest everything is all good. Okay, vada. So first one, in the small sphere la surface la da point irukke. So surface la point na and the potential vandu KQ divided by the radius. Okay, so I have marked that. Next one, due to this large sphere, okay, outer sphere, and the outer sphere kullada in the point, inside na it will be equal to the potential at the surface. I have equated and I got the point. So these are the things we need to study in this chapter. And next class la vandu on Wednesday, okay, 25th ku vandu 25th March la we are starting our session at 9 AM. 100 plus MCQs da anneki vandu we are going to discuss. And till this date, what are the important, or let's say high weightage chapters? Okay, it is not just with physics plus chemistry irukum. Okay, physics and chemistry irukum. Totala vandu, as I mentioned, many questions we will do it. And adu vida you will be getting the extra question PDF as well. Okay, so you will be getting more questions. So this will be starting from 9 AM. So you can just join the session on time. And as I mentioned, in the session we are going to discuss the high weightage. Okay, high weightage chapters mattunda inneke we will be discussing on this day. okay. So quiz மாதிரி தான் we are going to conduct. So இப்போ வந்து நீங்க வந்து join பண்ணினா definitely what you can do, you will be definitely getting what to say lots of confidence. Also gradually வந்து நீங்க வந்து உங்க ஃப்ரெண்ட்ஸோட காம்பீட் பண்றேன், ஓகே. அதனால you will be getting more confidence, உங்க ஸ்பீட் வந்து இன்க்ரீஸ் ஆகும், accuracy கூட இன்க்ரீஸ் ஆகும். and questions வந்து practice பண்றது வந்து ஒவ்வொரு ஸ்டூடெண்ட்ஸுக்குமே லேசியா they are dealing it. ஆனா வந்து I'm telling you, please do it. இல்லனா physicsல வந்து you are going to be in trouble. Okay, so adinala in the 9 AM session vandu you can attend. As I mentioned, high weightage chapters that we are going to discuss, and definitely this session is very expensive on a session. Okay, almost in the chapters mattum if you are studying 150 plus marks, okay, together from chemistry and physics. Okay, you can get it. So adinala I'm telling you, chemistry and physics combined are, I mean ஒரே ஒரு session use பண்ணி you are going to get 150 plus marks. அது வந்து அவ்வளோ easy அல்ல. We will be going for 6 hours 7 hours of session. ஆனாலும் proper breaks you will be taking, and of course you will become more and more energetic, and I'm telling you, you will crack this NEET exam by attending these kind of quiz sessions. So மறக்காம இந்த session join பண்ணிக்கோ. And I just wanted to know how many of you will be joining that session. Physics la vandu we will be covering electrostatics irukum, current electricity irukum, magnetism irukum, modern physics irukum, and I think 2 more chapters will be there. Okay, so in the chapters irukum. And chemistry la vandu I don't have the set of chapter names, aanalum I can say P block irukum, halo alkanes arenes irukum, hydrocarbons irukum, and I think solutions will also be there. So definitely there will be around 6 chapters by each of the teachers will handle, and as I mentioned 150 minimum you can score it, okay, together. புரிஞ்சுதாடா? ஸோ மறக்காம ஜாயின் பண்ணிக்கோ அந்த செஷன்ல. 9 AM தான் 25th Wednesday தான் செஷன் வருது. ஸோ மறக்காம ஜாயின் பண்ணிக்கோ. இந்த செஷன் வந்து அவ்வளோ crucial for you people. Okay வாடா? And I just wanted to know இப்போ இந்த மாதிரி detail ஆன sessions வந்து how effective it is for you people. So I just want the feedback also. I hope after the session I can just see in the comment box also. So let me see anyway. Thank you so much guys. We will meet on some other day. Not on some other day. I can specifically say on Wednesday we will meet, and definitely we are going to crack that 150 plus marks. Definitely we will rock on the day. And yes, okay, but try your best. Okay, otherwise even if you can't attend during that time also, attend after that. ஏனா வந்து we are planned the session, okay, and the session oda planning இப்படி தான் போகுது. We will be starting from easy question நால you will feel more confidence, and you will be get excited, you will become more curious. ஏனா வந்து easy questions வந்து உன்னால முடியும். Okay, so adu vandu again will boost your confidence, and that will help you to do more questions. Adha vandu namakku venum. Okay, so easy questions, moderate questions, and difficult questions, and that pattern that we are going to follow. So definitely, as I mentioned, you guys have to join. Thank you so much, and in the comment box la marakama unga feedback I need it, and please do mention your feedback. Thank you so much guys. Bye bye.